Hi, I am Clare Somerville, and I'm here speaking today on behalf of the Small Cell Forum just to discuss the work that we've been doing within the area of virtualization and small cells. So I was going to start today by giving you an overview of the Small Cell Forum, so who we are, what we do, and how we work. And that's probably quite important to understand the context and the scope of the virtualization work that we've done. And then a kind of brief introduction to the drivers and the reasons why we started looking at virtualization over the last year or so. And then just a more detailed view about that work. I was going to focus in particular on looking at the various decompositions that we've been investigating of a small cell. And finally, just a summary of where we're going next, as this is still very much a work in progress for us. Okay. So the Small Cell Forum, it's an industry group. We were founded in 2007, so this is right back at the very beginning of small cells, or femtocells as they were known then. Our purpose is to accelerate small cell adoption, and we do that by trying to ensure that there's a good ecosystem. So that's a multi-vendor ecosystem. If there's any issues within that ecosystem or problems, then we try and investigate as a group in how to solve them. And we're also interested in making sure that it's open standards, so it is multi-vendor and interoperability is important to us. And then finally, and very importantly, is educating the marketplace about the benefits of small cells and giving examples about how you can deploy small cells in various use cases. So member-wise, we've got, well, hopefully lots of you see your companies up there. We've got 62 operators, which is 3 billion subscribers worldwide. And then 78 different vendors of small cells. And that covers everything from SoCs, protocol stack vendors, wireless backhaul, small cell base stations, security gateways, all the way up to people that do complete end-to-end solutions. So it's quite a large body, and we cover most of that ecosystem participating in our work. So the way that we work now is that we operate by a release program. So we're very operator driven. And so what we'll typically do is collect the requirements from different operators related to any issues that they see or any areas that they'd like investigating. And then that gets turned into a series of work items. And that work item is then handled by our kind of specialist groups. We have groups that cover radio protocols, networking aspects, regulatory, IoT, big marketing group. And as those groups get together and they do all their individual work items, we end up with a release. And that release will hopefully cover everything you wanted to know about the questions that we wanted to answer. And then we make that release publicly available on our website. Okay. So we started the release aspects back in 2013 by looking at the different market segments for small cells. So we started where small cells started, in the home, and then moved on to look at enterprise. So we're covering small offices, medium offices, shopping malls. Then a kind of like a year and 2 releases just looking at urban. So outdoor small cells, open access. And we've just recently completed our 5th release, which is to do with rural and remote. And that's actually due to get published next week to coincide with MWC. So rural and remote, it's coming up. It sort of covers rural communities, kind of remote aspects. It's like an oil rig example. Also includes transport, so cruise ships, planes, and things like one-off events such as like a music festival. And so with completing of that, we've now sort of looked at each of the individual market segments for small cells. And we've now been embarking on our first kind of like horizontal theme, which is virtualization, where we're expecting it to impact slightly all those different market segments in some way. Okay. So I guess it's like, why have we decided to look at virtualization for that first kind of horizontal theme? So before I move into this, I guess having sat here and listened to all the talks yesterday, is our scope as an organisation is probably more closer term than iJOIN. We are looking sort of pre-2020, and as we kind of working with what's out there in the industry, we do have less flexibility in what kind of approaches we can take and what new work that we can do. We're kind of trying to take today's current ecosystem and in many ways see if we can apply virtualization to it. Okay, so there are two big themes going on at the moment. There's HetNets, so we have our overlaying macro layer, and then inside that, it's well accepted now that small cells are an efficient and effective way of deploying either the extra capacity that you need or the extra coverage that you need within that macro cell layer. And then conversely, you've got network function virtualization, which is all about turning from specialized hardware onto sort of general purpose compute servers, and more of a split between the control and data plane. And then just a statement at the bottom that where you have virtualization in the radio access network, it's Cloud RAN. So I think within this room, I don't really have to sell the fact that we think we can apply virtualization to small cells, but outside in the wider domain, I think you still do. It is typically viewed that they are two sort of opposites and alternatives, not something that could coexist together. So within the small cell forum, we're really trying to look at, can we apply those virtualization techniques to today's small cell architectures? So there's two reasons that we're interested in that. One is that in the small cell architecture at the moment, with it distributed, you're having your intelligence at the edge of your network, whereas Cloud RAN gives you your centralization and your intelligence at the center of the network. So the question is, if we use virtualization, can we take some of that kind of more centralization techniques to enhance the cooperation between clusters of small cells? So can we help mobility? Can we apply some of the advanced LT features such as more comp modes? And then also as Cloud RAN is taking off, we are just as likely to be trying to interact with a kind of Cloud RAN-based system as we are with a distinct distributed macro cell. So by doing virtualization, would we help that at all? Okay. So within those HetNets, when we've got distributed, we've got sort of potentially Cloud RAN, we think that to get the most out of return on investment on small cells, you need to kind of fully interwork with whatever you have else in that HetNet network. So that could be macro cell, could be Wi-Fi. And I guess finally, there are lots of people starting to look at virtualization in small cells as virtualization is getting much more of a common theme. And as a kind of small cell forum, we want to make sure that that's done in a way that maintains the ecosystem, maintains multi-vendors, maintains interoperability. And we think we do that by trying to provide some leadership in that area. Okay. All right, so this is just running through sort of pre-2020 what the expectation is for small cells out there and also Cloud RAN. So the prediction is that by 2019, 70% of mobile operators will have some kind of small cell network. And of that 70%, just under half would also be having virtualization in parts of their RAN. And then conversely, out of 90% of operators that do Cloud RAN would also have some kind of urban small cell. And so going forward, you are really seeing that you are having both virtualization in terms of Cloud RAN and small cells together in the same network. So trying to reapply those virtualization techniques to small cells has the potential to be very beneficial. So I mentioned at the beginning that we are very much driven by our mobile operators. So the specific questions that we had from them are really to do with what's going to change when we apply virtualization to small cells versus virtualization to macro cells. Are you going to get the same benefits? Are they going to be slightly different benefits? And in particular, what are the business benefits? So is it going to be worth their while doing this work now? So because small cells are distributed, they're single nodes, whereas virtualization tends to go hand in hand with either cloudification or centralization. Is the current architecture that you have of this single node, is that going to work going forward, or do we need to have a look at some kind of new architecture to suit that? And then as 5G is viewed as being ultra-dense networks, is viewed as having virtualization, is there some kind of phase roadmap or stepping stone that we could have to 5G? And then finally, again, it's emphasizing that multi-vendor ecosystem. Can it be done in such a way that it's not proprietary, but it's something that could work with multi-vendors, but still support innovation? Okay. For the kind of detailed look at the work that we've been doing, I've decided to focus on the architecture decomposition of small cells that we've been doing, as I think that's probably quite applicable to iJOIN, because you've done kind of similar work yourself. So we started off with our work by these are the ETSI use cases for you. And in particular, 3 of them, use case 4, 5, and 6, we think can probably be applied to today's small cell networks. So we've looked at use case 4 and 5 are actually related to our rural and remote release that we're just doing now. And that's been done in terms of virtualization is often viewed as your ability to scale up a network. But in addition, you can potentially scale down a network. So in rural and remote, where your networks are much smaller and fewer number of users, that ability to scale down and perhaps share hardware, or to move some of those core network functions to your single end node, that's potentially very beneficial for these rural and remote market segment. Whereas the use case 6, the virtualization of the mobile base station or of a small cell, that's going to be our main theme for our virtualization release. Okay, so there's going to be some terminology differences here between the slides I saw yesterday and today, because each new group that looks at something comes up with their own terminology. So we have, we've tried to follow the ETSI, NFV terminology where possible, but we've split our small cell into a virtual network function, which we're calling our central small cell, and then as a physical network function, we term that our remote small cell. And then this is again taking one of the ETSI diagrams, and it's on the right here we've got the kind of management functions of the orchestrator and the various managers. Then you've got your hardware down here and the hypervisor, and then on top of that we locate our central small cell as a virtualized function, and that's then got its communication off to a remote small cell. And then the connection between the central small cell and the remote small cell we call front haul. Okay. Again, this is a slightly different representation of the RANAS slide with, so instead of having these functions horizontally, vertically, we've gone for horizontal. So we've taken the various parts of a small cell and we've split them into components. So up here, we start with our applications layer, and there we're including operation and maintenance and features such as SON. Then we've got our different protocol layers, so PDCP, RLC, MAC, physical layer, and finally an RF. We've looked at the potentials of splitting the MAC and splitting the PHY in half. So here I've just gone for describing them as upper and lower components. So the first thing to show is a standard cloud RAN split. So we have a remote radio head as the physical function, and then all the other parts are then centralized in the virtualized function, and the connection between them is CIPRI. So why haven't we just gone ahead and accepted that? And it's really because of that issue with the front haul. It has its benefits in the fact that CIPRI is standardized, so that there would be a ready-made API that could get used. But we're going to typically need fiber and also very tight timing constraints. Whereas today small cell networks tend to be deployed on gigabit Ethernet for the last mile. So, so it's not really feasible to accept that people would want to do fiber to their small cell connection. So the danger of just picking that interface is that we want to accelerate small cell adoption, But if you've limited the number of users or operators that can implement it, then it's not going to get adopted. And similarly, that means that you'll just end up with the current kind of Cloud RAN approach or small cell approach, and there's being viewed as two distinct articles. So the other splits that we've gone through, so we did investigate various PHY splits. The one that had preference within the forum was the iJOIN A.2 split, which so you've got your user processing or your cell processing in the PHY, and the A.2 is in the middle of the cell processing. So from our perspective, that gives you quite a big reduction in bandwidth that you need, sort of 2 times less. And you don't need to match the SIPRI, very low latency of 5 microseconds. But it's quite a nice simple split. So we don't have the ability to go ahead and look at various other algorithms within the PHY. So just looking at the cell processing is just kind of a simple one, but because it's still within the PHY, we'd still have to look at some kind of API definition to support multi-vendors and interoperability. So that's kind of a negative. We also looked at this Mac-PHY split. This is advantages for us within the forum in terms of multi-vendors because we have a FAPI that we defined. So 3GPP, we're never going to define an API between a Mac and PHY because they will only define the interfaces to the E node B. But within the small cell ecosystem, the reality is that you tend to get one vendor that makes the PHY and then a different vendor that makes the protocol stacks. So as a forum, we looked at defining some kind of interface that's now been quite well accepted, and that has just helped the matching of PHYs to protocol stacks. So in terms of a decomposition, we do actually have this split, some kind of API that could get used. So we also looked at within the split MAC, and in terms of how you split a MAC, then all the scheduling functions could be centralized, and once you centralize those scheduling functions, you help the cooperative nature a lot, but then the proposal was that the HARC retransmissions could be put on the remote small cell. So that's going to help a lot with meeting that kind of 8 milliseconds HARC turnaround time. But again, it's in the middle of the MAC, so you would have to look at some kind of definition of API. We briefly looked at RLC and MAC. That's a surprisingly complex split to do, just because of the way LTE works, and again would require some kind of new API. Another reasonably attractive one in today's networks is the split between the PDCP and RLC, because at this point here, you have moved pretty much all your real-time functions onto that remote small cell, but by centralizing the PDCP, that means you've centralized things, features such as your ciphering. You could support latencies on your front haul of sort of up to 30 milliseconds, which is the same latency that we think that you need on a small cell backhaul. And you can still support some enhanced features, such as some of the comp modes would still work in this scenario. And there's also, this is the same split that's used in 3GPP dual connectivity. So there's a potential there for some kind of API to get defined by 3GPP. Okay. And then the final is just to show the standard split we have now. So we're still kind of, at the moment, looking and investigating the different pros and cons of those splits. So as well as implementation-wise, there's the effects it would have on front haul and the bandwidth and latency requirements. There's the kind of performance features it has. And we think the reality is that you're not going to come up with one split that's going to suit everything. It's more that we can identify the pros and cons of the splits. And as a forum, we might be able to do some more work in more detail on some of the splits. But which one you pick is going to be highly dependent on what kind of front haul connection you have, so what latency you can tolerate and what bandwidth you have available. So pulling just kind of 5 of those splits out, spread throughout the stack, you can start charting what their various requirements are. So the top line is front haul latency. So with a CIPRI and a split PHY, you need what we've called ideal latency. So here we're talking about latencies of less than 250 microseconds. And then when you come all the way up to the PDCP split, you're getting up to non-ideal latency, which we describe as anything up to 30 milliseconds. And then the lower one is all about the performance improvement. So obviously when you've got CIPRI and you've centralized everything, then that means you've got full coordination. You could support all the comp modes, including features such as the joint reception. Whereas then you get the PDCP, so you could have some benefits in handover and mobility support, and you could support the coordinated scheduling beamforming mode of comp, but it's much less, and what you find is that they're exact kind of opposites of each other. So there's good points and bad points for each individual split that we've kind of looked at. Okay, so I was just going to summarize where we are at the moment with virtualization. So we think it's going to be increasingly applied, certainly within core networks, and we've already been doing that relating to those NFV use cases 4 and 5 within our rural and remote, in trying to use it as kind of a barrier to reducing the cost of small cell deployments for rural and remote. The use case 6 is our main focus of our virtualization theme, and it is very much dependent on what you do, on what that front haul connection that you have available is. I mean, to try and kind of look at those splits and identify the pros and cons, and then we are doing sort of a comprehensive analysis related to the decompositions, the coverage and capacity benefits that you get, various transport characteristics, any deployment-related issues, and a business case analysis for those various splits. Timescale-wise, I think we're our first sort of publication of this study is due for June 15, so about a month after all the iJOIN papers. So I guess we can quote you rather than the other way around. And yeah, that's it for an overview. So I don't know if anyone has any questions.
On one of your last slides, you list all those options where the split could be done, and you say big answer comes in June 2015. Do you have already any indication where you would say this looks very likely to be the good best compromise in terms of split?
So we don't really have any answers yet. In particular, we're waiting for the business analysis to still get completed. We can see that by picking one of the splits, that I think that there's some kind of API that people can come around. That's going to be very useful, because that is more likely to get people building systems, and you're not going to end up with lots of different proprietary variants of it. So we are kind of favouring that purely from a practical way going forwards. But you can have those APIs all the way from just above from CIPRI to the PDCP to MAC-PHY. So it covers, APIs are still available across all those different use cases. And it's very much going to be what latency is on your front haul, how many hops are you going to have between your where you're putting your centralized virtualized functions and your small cells. And you can it's quite easy to match once you know your front haul, it's quite easy to turn around and say that's the use case that will get you probably most benefit. But the front haul options are so deployment specific. So that wasn't really an answer because we haven't got one.
So as an example, so Vodafone, we have 30 countries.
Yeah.
And in each country we have a very diverse history, mergers, and so on and forth. So there is no one size fits all front haul, even in our company. But we want to have one global technology solution, not 25 flavors of how to build networks. That's a real challenge also.
Yeah, so the problem with having a sort of one for all is that you end up taking the solution that tolerates the worst front haul you have. So I mean, one of the benefits of virtualization is that you could support a couple of different aspects of front haul, and the virtualization of the central parts would make it easier for them to get deployed together in the same location on the same pieces of hardware. But the only split that would work with all today's small cells is that PDCP RLC split. But you're getting some benefits from virtualization, but you could get a lot more in the situations where you could perhaps support a Mac-5 split. So it's just obviously there's trade-offs.
I saw a list of potential functional split that you are saying describing with pros and cons and so on. Do you plan to make a narrowing of the previous slide,
that one
of all the possibilities, also in the view of, let's say, somehow promoting some outcome from small cell forum to 3GPP? This is the big question from operator point of view. So even if for operators it's very welcome to standardize in theory every kind of API in all the 7 possibilities, I don't know, at the end what will be the survival of the candidates, and if you have a plan to exploit somehow your result in 3GPP and just kind of frame.
We are going to narrow down the splits, the recommendations. We haven't agreed that internally within the forum yet. We've kind of identified, again going back to front haul, sort of an ideal latency of 250 microseconds, then perhaps a good delay, which we're calling up to about 5 milliseconds, and then a non-ideal delay, which we call up to 30 milliseconds. So we're certainly, the aim is to try and come up with a use case for each of those latencies, and then explain the benefits of them and the pros and cons. But we haven't, within the forum, we haven't kind of formally got together and said these are the splits that we should use. In particular, that good delay one of 5 milliseconds there's several options that could get used there.
Okay, and regarding the impact in 3GPP, and your precise idea of what can be?
There's been discussion, I guess the main split that relates to 3GPP is this one here, the PDCP RLC, for their dual connectivity. So if we're interested in that one, it's, for us, it's important that 3GPP do standardize that API for that dual connectivity so that we could reuse it. There isn't any plan for the other APIs because I guess in terms like our Mac-5, we've defined an API within the forum, but I'm not sure that we'd get 3GPP to standardize it. Oh, yeah, sure.
I'm part of the small cell forum too, and the way we work typically, and the big example here is with iJOIN. So the RAN interface for small cells in 3G was created by a consensus within the small cell forum by small cell forum members, and then those members who were also members of 3GPP then took papers to the 3GPP meetings and got the iJOIN standardized through 3GPP. And I think if there is a consensus for, so I think to Claire's point, to your question, I think the favorite API, if there is no API, if there is no defined interface, then the job of the forum would be to form a consensus around a proposal, and then take that proposal, individually, individual member companies who are members of 3GPP will take that proposal to 3GPP. That was your question, yes?
Mm.
Okay, thank you very much.